All right, so going to continue talking about looping concepts today. We have a whole bunch of stuff to talk about today. Probably going to go for the entire class period. If my timing is correct, I'd highly recommend that you open up this PowerPoint on D12 and follow along, or also have a terminal open to write some of the code we're going to talk about today. So with that, any questions or comments about looping that we've talked about so far? Anything not make sense up until this point? Looping questions, for loops, while loops, any loops. All right. So help night, we're going to, this week, it's going to be Monday and Thursday. Today from 4:15 to 6, and Thursday from 6:30 to 8. So as usual, just send me an email if you're going to be there. Otherwise, I'm not going to show up. But if you let me know ahead of time that you'll be there, I'll be there. So one operator that we haven't talked about yet is the modulus operator. So one of the things you might have noticed that when you were doing integer arithmetic, specifically dividing two integers, is that any remainder is discarded. However, with the modulus operator, we can find the remainder of a division operation. So we can say variable or literal, and then percent sign, which is referred to as the modulus operator, and then another variable or literal. So we can store the result of this operation. We can say variable equals, let's say index is our variable, mod 2. So it's going to take whatever variable we specify, in this case index, divide it by 2, and then store the remainder in this particular variable. Or we can use the modulus operator directly in an if statement. So we can say if index mod 2, and then if it's 1 or non-zero, it will be true, and if it's 0, it will be false. So some examples of the modulus operator. So taking 10 divided by 2 is going to perfectly divide into 5. So 10 divided by 2, there's no remainder, so 10 mod 2 is 0. However, when we take 10 divided by 3, that equates to something like 3 1/3. So what's going to happen here is the integer division is going to result in 3, because remember, when we're dividing integers, we drop any remainder. But when we mod 10 by 3, we have a remainder of 1. So just again, think of the modulus operator as get the remainder from the division operation. So if we were to say 10 divided by 3, the result from that operation would be 3. But if we wanted to get the remainder from that, we'd say 10 mod 3, and the remainder from 10 divided by 3 would be 1. So just another example quick is 21 divided by 2 is 10, and there's a remainder of 1 in that division. So when we say 21 mod 2, we are getting 1. So the main thing that we would use this modulus operator for is finding even and odd. So to find if a number is even, we would say variable name or number, mod 2, and then if it's equal to 0, then the variable is even. Because if we can divide a number by 2 with no remainder, that means that it's even. Again, perfectly divisible by 2. So if a number is odd, we would say variable mod 2 not equal to 0. So if there is a remainder, so if we can't perfectly divide it by 2, then it's odd. Otherwise, we can also check to see if a number is divisible by any other number. So we can say variable name mod and what we want to check if it's divisible by, and if it equals 0, then it is perfectly divisible by that number. So let's say we wanted to see if 100 was, well, let's say arbitrary number, 100 is divisible by 5. So in this case, we would say 100 mod 5 and equals 0, and since it is divisible perfectly by 5, the condition would be true because 100 is perfectly divisible by 5 with no remainder. So example that I'm going to go through really quick is we're going to print even numbers from 0 to n. One thing I'm actually going to talk about a little bit later is talking about insightful comments. So when you're declaring variables like I and n, I kind of want you to talk about what you're going to be using them for. So you would say I is index, and then n is number to print until. So this would be something that I consider an insightful comment. This doesn't necessarily describe what you're doing, but it describes what your intention is behind the numbers you're using. Remember that we can say a comment with 2 slashes. So 2 slashes will discard everything on that line. Or if we want to say multiple statements, we could say slash star and then slash star star slash. And that will be a block comment. So just think about when you're writing your code, you want to be describing why you're doing what you're doing. Not necessarily what you're doing, but why you're doing it. So our loop would look something, or first of all, we need to prompt the user. Again, what we're doing in this program is printing from 0 to n only the even numbers. So we would say printf, enter the limit, scanf, %i, and ampersand n. So that will read in the limit into n. So we can say for I equals 0, which is our initialization. We can say I is less than or equal to n, and then we can say plus plus I. So what would I want to write here then? Can anyone? So if I wanted my if statement to be true when I is divisible by 2, what would I want to write here? Yep, and then I'd want to write one other thing. So I have this right now. So if I is divisible by 2, but we also have one more component. Right now, this is actually going to be, this statement's going to execute when I isn't divisible by 2. Because remember that if, let's say we're on 2 and we say 2 mod 2, that's going to be 0 because we have a remainder of 0. And in C, if statements, 0 is false and non-zero is true. There we go. So when we say something like, when we have an expression here, if this expression is true, then this is going to essentially evaluate to 1, which is also going to be true. So you can either have a true expression or a true number. So non-zero for true and 0 for false. So all I would say is printf %i, and then I. So that's going to print if it's divisible by 2. Then at the very end of our program, just going to printf a new line, and that should be it. Now there's one other thing in this program. I'm just going to run it and see if it works or not. I don't know if it will for sure. Oh, I forgot to talk about that too. We'll talk about that in a little bit. Yeah, so it's going to print all of the even numbers up until 10. So that's pretty straightforward. So one thing I didn't put on the agenda, but one thing I did do is I did put the compiler in strict mode. So essentially what that means is there's a couple different things that the compiler isn't necessarily going to warn you about by default, but aren't necessarily up to the standard C coding, or the C coding standards. So one of the things that I told you didn't have to do before is say return 0 at the end of your main function, but now it's going to return, or it's going to warn you. Stop it. It's going to warn you if you don't return something, because that function is an integer. It's supposed to return an integer, so you should say return 0 at the end. Now, you don't necessarily have to. This is just a warning. If the output from the compiler is just warnings, you don't necessarily have to do anything. But hopefully these warnings will help you out a little bit when you are writing your code. So one of the things that it will certainly help you out. A lot of people will forget to put the ampersand on the scanf. So one of the things that this will do is it will say warning format %I expects of type int pointer. So when you see that, just think I'm missing an ampersand on my scanf. So just if you start seeing a lot of messages that you haven't seen before, that's why, because I put the compiler in strict mode, so it will notify you of things that aren't necessarily the way you want them to be. So that's our program that prints from 0 to n if the numbers are even. So if we wanted to print if the numbers were odd, we would just go back and say not equal to 0. Or remember, we can say implicitly if I mod 2 equals 0. Because if there's any remainder, then this will be non-zero, which will be true, and then we'll print out our number. So even, forgot to change that ampersand back again, so we'd scroll on up here. We'd say an ampersand n 10, and that will only print the odd numbers. So, and then if we wanted to do something like this, we could build it even more, and we could say if divisible by 5, then we could say 0. So this will print out everything divisible by 5. So 0, 5, 10, 15, and 20. One thing to note about this program is it will also find 0 to be divisible by everything. That's not necessarily the case. It just happens to be how the language works. So we can actually, if we do something like, we'll just at the very top. This will crash. This should crash the program instantly. So we should say 0 divided by 5. And we can just put an expression there and not start anywhere. Oh, it doesn't actually crash it. It's interesting. But theoretically, when you take... Oh, that's why. Never mind. Just ignore what I was just saying there. I had it the wrong way around. So if you take a number and you divide it by 0, it's going to crash the program, just FYI. That's what I was going for. Instead, I had thought in error that taking 0 and dividing it by 5 would crash the program. It doesn't. If you have 0, how many 5s are in it? 0. So that's all there is to that. So going back. So that was our examples of the modulus operator. Any questions about that right now? All right. So now we're going to talk about advanced for loops. So recall that our for loop execution order is like this. We start out, we initialize the variables as described. We can test the condition. If false, if the condition, which is the second part of the for loop, then we jump down to number 6, which is continue execution after the block of code. So if the condition is true, we execute the block of code. And after the code is done executing, we increment the index and continue on to test the condition. So one of the things I was talking about on Friday with a couple of people that were having some issues were components of the for loop are optional. So you don't necessarily have to specify the you don't have to specify any of the components of the for loop. You can leave any of them off. So in the first, these are all valid for statements here. So in the first one, we're leaving off the initialization. We don't have to assign a value to any variables. We don't necessarily have to do that. In the second one, we are leaving off the conditional test. We don't necessarily have to test a conditional, but if we never test a conditional, the loop is going to go on forever, and it's just going to continue going on forever and ever and ever. And finally, we don't actually have to have any statements at all. We can say semicolon, semicolon, and it will essentially act as a loop that just goes on forever. Components of the for loops are optional. We'll talk more about why you care about leaving things like the condition and the increment off later. So we can actually specify multiple initialization, condition, or increment statements too. All we have to do is separate them by comments, or commas, I should say. So if we have two variables, so this is, let's look at initialization and increment. So just looking at our initialization statement, which is the first component right here. Let's say we have two variables, I and j. We can actually give them both values at once. So we can say I equals 0, comma, j equals 10. And we could string as many different assignments together as we wanted to. And then looking at increment, we can also string as many increment or other modifying operators together. So we could say plus plus I, comma, minus minus j. Or recall, we can also say other mathematical expressions. We can say plus plus I, comma, j plus equals 2 or something like that. So just keep in mind that you can specify multiple initialization or increment operators. All they have to do is be separated by a comma. And then for comparison, so that's the middle one, just remember that we can string multiple logical conditions together with our logical operators, which are double and ampersand, double pipe, or the not sign. So again, the 2 and ampersands are and, so both of the conditions must be true. The 2 pipes are or, so either of the conditions can be true, and the final one is not. So that's inverting a condition. So in this case, we'd just say I is less than 10 and I is not equal to 5. So as soon as so this statement will be true when I is less than 10 and I is not equal to 5. So as soon as I equals 5, the statement is going to end. So I haven't really ever seen too many of these type of conditions where there's multiple comparisons, but just keep in mind if you come across a circumstance where you need to use multiple comparisons in your loop, that's completely possible and that's completely valid. So code blocks with loops, we don't necessarily have to provide a block of code for a loop. If you put a semicolon at the end of the loop statement, the loop will immediately skip to step 3. So in this loop, all this is going to do is going to take I, set it to 0, and then ignore step 3. So looking at this, we're going to ignore step 3. So we initialize it to 0. We test the condition, so I is less than 10, which is true. So then we're going to skip the block of code. We're just going to increment I, and then we're going to go back to 2, and then go back to 4, and 2 and 4, and 2 and 4, until we get to 10, and then we're finally going to get to 6. So I want to talk about this because I told some people I'd explain it on Friday because people were accidentally putting a semicolon at the end of their for statement. So what's actually going to happen here is it's just going to increment I all the way to 10, and that's it. Regardless of whether or not there's a block of code connected to the for statement, if you put a semicolon at the end of your for statement, it's just going to increment I all the way up to 10, and that's it. So that's all this for statement does. So again, that's the execution order. If you put a semicolon at the end of your for statement, it's just going to ignore the block of code at the end. So now we're going to talk about a couple of advanced statements that we can use inside a for loop. So if at any time in the for loop we want to immediately stop executing the loop, we can say break. So at any time in the loop, all we have to do is say break, and we will immediately jump to number 6, which is continue execution after the block of code. So at any time inside our block of code, we can say break. We can say break immediately, and our loop will just stop. We can use that for for loops and for while loops. So in this case, normally this loop would go from and print from 0 to 10, but in this case, as soon as I equals 5, we're going to break. So let's just look at this really quick here. I equals 0, initialization, I is less than 10, comparison, and plus plus I to increment. Then we say if I equals 5, we're going to break. Remember that if we only have a single statement with our if statements, we don't have to have brackets. You can just have a single statement with an if. You can put it on a new line if you want to, or you can put it on the same line, so you can say break. Now this applies to any other statement in C. So if you have an if statement and you have a single statement that you want to run with your if conditional, you can just say plus plus I or A plus equals 10, or do any number of operations on the same line. So if I is equal to 5, we're going to break. Otherwise, we're going to printf %in I.
So break just stops the code, right?
So what break is going to do, as soon as we see break in our, well, just for simplicity, we'll go like this. So if I is equal to 5, then we'll execute this break statement, and what that means is we'll immediately start executing statements after the for loop. So we see this break, we're immediately going to go down to line 13 here. So just keep that in mind. This should output 0 through 4. Yeah, so that outputs 0 through 4. As soon as I equals 5, the loop is going to stop, and we're going to continue execution on line 13. So that's one of the different keywords we can use inside a loop to control its function. So if we were inside a for loop or a while loop, we can use that statement to immediately end the loop and continue executing code. The other statement we can use is continue. So we can use a continue statement to immediately start the next iteration of the loop. So essentially what this does is it stops and it jumps immediately to number 4. So this is our for loop execution order. So if we're inside our block of code in step number 3 and we see continue, we're immediately going to go to step number 4. We're going to ignore the rest of the statements inside the block, and we're going to immediately increment the index. And, sorry, this is wrong. This continue statement the continue statement should jump to number 4 and not to number 5. We do increment the index during a continue statement. Let me edit that quick here so you can be confused. So this is actually what it should be. So the continue statement jumps to the increment the index line. So as an example of that, let's say when I is equal to 5, we want to skip 5 and not print it out. We would say continue. And what will happen here is we'll print 0 through 9, but we're going to skip 5. So you can see 0, 1, 2, 3, 4. Then 5 is skipped because when we said continue, we immediately incremented the index and went to test the condition and started the next iteration of the loop. So 5 is skipped, but we do still print 6, 7, 8, 9. And can anybody remember what we would do if we wanted to print all the way to 10? Yep, so we just change that to less than or equal to. So just remember that we use the continue statement to immediately start the next iteration of the loop if for some reason we did not want to execute the rest of the statements. So that's so we talked, that section was pretty much about break and continue. Any questions about break or continue?
So if you did continue in that code, it would just do the plus plus I and then do it over again?
Yep, so it continues executing all the other steps, but it immediately stops executing the block of code.
Okay.
I'll try and explain it one more time here. So again, we just skip 5 here, but the only reason that 5 isn't being printed out is because the printf is being skipped. The increment's not being skipped, and the test isn't being skipped, but every other piece of code is being skipped. So try and...
Okay, I get it.
So we can, let's just, I'll print it out twice. So we'll have a couple different statements here. We'll have, and then I. So just a couple statements to see that we can skip multiple statements. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. But see, there's no 5, 5 because when we say continue, we skip all of the rest of the statements inside the for loop and continue on with incrementing the index and then testing. So again, as soon as we see a continue statement in our code, we jump immediately to number 4. And if we see a break statement, we jump directly to number 6. So one of the things we can do with break statements is, remember I showed you that one for loop that looks something like this. So there was a for loop with nothing in it. So there were just 2 semicolons. And what's going to happen right now is this statement's simply going to run forever. And sometimes we want a for loop that will do that. That will just loop and loop and loop and loop forever and ever and ever until we tell it to stop. So that's one of the things we can actually use the break statement for. So we can rewrite this statement a lot like we could write a while statement. So we would say, while we'll declare I and set it to 0, and then we'll say printf I, and then we'll add 1 to I, and then if I equals 10, we will break. 0 at the end of our function because it's integer. So all this is going to do the exact same thing. It's going to print from 0 to 10, but it's going to stop for different reasons. So this loop is going to loop forever, but as soon as it sees that I is equal to 10, it's going to stop looping. Yep.
I thought. No.
Okay. So we can do a couple different things with this code. So there's no reason why I should have this increment out here when I have a perfectly reasonable spot for an increment right here. So I can put that increment up there too. So looking at this code, it would print 0 through 10, but just for slightly different reasons. So that's one reason we might want to use the break statement sometimes. So just keep the break and continue statements in mind. They come in really handy when you're approaching problems that aren't necessarily purely incrementing, but they are very similar to. All right, so nested loops then. So we can place loops and if statements inside other loops and if statements. So recall going back here that there's no problem. We can put an if statement inside this loop. That's perfectly valid. We can put another if statement. We could say if I. This is obviously never going to work, but we could say something like this where we put a loop in, or we put another if statement inside an if statement. And remember that we can put as many if statements inside each other as we want, and we can put as many for statements inside each other as we want. So all we have to do, we say a for statement just like we said before. Yep.
Variable is declared inside of like the second for statement. They won't be recognized in the first one.
Yep. Excellent point. That's completely true. I'll talk about that briefly when I'm doing the example. So just like any other for loop, we just put it inside the other for loop. So what's going to happen is code body is going to be executed, and then it's going to execute the code body of in the nested for loop with the same precedence as before. So the outer for loop when the outer for loop executes its block of code, it's not going to be able to execute again until all 6 steps of the inner for loop have been executed. And every time that the inner block, so this would be referred to as the outer block. So there's essentially 2 levels of for loops here. This is the outer block, and this is the inner block. So every time that the outer block is executed, we execute all 6 steps of the for loop. So just keep that in mind. I'll go through and, yep.
So if you do a break in the inner block, does that end both for loops?
No. So excellent question. So if we do a break statement inside our inner for loop, all that does is end the execution of that for loop. It does not it does not bubble up essentially. So if we break inside our inner for loop, it's not going to also break outside of our outer for loop. So very, very good questions today, guys. So my example for this is I'm going to count to 10 n number of times. So just talking about what my variables are doing. We'd say for I equals 0, I is less than, just for now, I don't care to read in because it takes too much time. We'll just say n is 10. So we're going to print 0 through 10 10 times. So then less than 10 plus I. And now for our inner for loop, we'd say for j equals 0, j is less than 10, or less than or equal to 10, then we say plus j. And then for our for loop, we'd say print out %i space to give it a little spacing, and then j. And then after, so that's going to print 0 through 10, but then after we print 0 through 10, we want to print a new line. So we'd say printf /n to print a new line after that inner loop's been executed. So we'd say 0 through 10, and then we'd say new line, then we'd say 0 through 10 again, and we do that 10 times. Let me see this real quick. Change that to n so we actually are doing what I want it to do. And we can see that we print 0 through 10 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's essentially an example of a nested loop. We don't just have to have a loop inside our nested block here. We can have multiple statements. So not only are we saying 0 through, or we're not only doing this loop inside the nested block, we're also printing out inside the block too.
Why does it print 10 times? Why is it printing?
So why is it printing 10 times, or why is it printing 0 through 10?
10 times.
So that's what the outer loop is doing.
Okay.
So we're looping 10. So let's change this number so it's a little more understandable. So we're going to loop 5 times. So we're going to say essentially. So here our condition is going to be I is less than 5. So that means we're going to loop 5 times. So I'll go back and explain it again. So there it goes 5 times. So that's all based on the outer loop. So the outer loop controls how many times we're going to do the inner loop. So since we're doing it 5, we're essentially, what this outer loop is saying is we're just going to do the inner loop 5 times. So that's nested for loops. We're going to talk lots more about nested for loops. So, okay. I feel like I had something else to talk about before that. I guess not. So, I'm going to continue on to assignment 5. So you can find assignment 5 on D2L, table of contents, week 9, assignment 5 under the content section. So assignment 5 is a big one. I'll be real honest. It's gonna take a significant amount of time to work on. I'm gonna go through it really quick here and try and describe what it does, and then we'll have some time for questions and to talk about what our next steps will be in this course. So for this assignment, we'll be working with loops. I want you to write a program which prompts the user to make a choice, then performs that choice, or an action based on that choice, I should have said. You should keep prompting the user to choose until they enter 0, and your program should have the following choices. So print x to y, like we did on Friday, ascending if x is less than y, or descending if x is greater than y. I'll go back through these. I have an example program that I'll run, and I'll show you exactly what I mean for each of these. They might not make sense right now, but I'll come back to them. And then print a rectangle x by y, and print an isosceles triangle n tall, print a diamond n tall. So if it's even, we're going to only print n minus 1. I'll talk about that more later too. Then we're going to print a filled staircase n tall. We'll print an outline staircase n tall. Sum the user input until they enter 0, printing the result, and summing the user input until they enter 0, printing the running sum. So I'm going to run my sample program here really quick, talk about all the different things I want you to do. So in order to run the sample program, you'd say dist assignment 5, and that will run the sample program. So the very first thing that you should give the user is a menu like this. So you give them all the different possible outcomes, and as soon as I push 0, the program exits. So the very first thing is x to y. So I'd say 10 and 20, and it's going to print 10 all the way through 20. So right here, 10 through 20. So that's ascending. However, if x is greater than y, we need to print from x down to y. So instead of printing from 10 to 20, since 20 was entered first, we print from 20 down to 10. All right, so that's essentially x to y. So moving on to rectangle. So we enter the length followed by the width. So let's say we just want to print a square. It was 5 by 5. It would output with stars what we want for the shape. So 5 by 5. Also output different sizes. We could say 10 by 5. We could say 2 again, 5 by 10. And print out a bunch of different rectangles. So that's what I want you to do for that. So for isosceles triangle, I want you to enter the height, so say 10, and it will output a isosceles triangle which meets the mathematical rules for that triangle. So it's going to be counting from 1, 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. So when I say enter the height, that's not starting from 0, that's starting from 1. So just count it out, say 10 tall. So that's what I want for the triangle. For the diamond, we're also going to enter the height, but this one's going to be a little bit more tricky. So I want you to print out a diamond like that. Again, using the asterisks. So this is actually going to be 1, 2, 3, 4, 5, 6, 7, 8, 9.
So that would have to be ascending and descending for you to make it like that.
Yeah, so there's going to be a bunch of different for loops to make that diamond. So one of the things I talk about in the assignment is if even n minus 1, so we can't make a diamond that's even because there's always going to be this center column here, so it's always going to be odd. So if the user does input 10, then the diamond should only be 9 tall. So if you input 9 or if you input 10, the diamond will be the same height. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 and 10 will be the same. 7 and 8 will be the same. So again, if it's even, then n minus 1 tall. That's honestly, the diamond's going to be really tricky, but it's a great learning experience to really start to think about how for loops actually work and how we can work on things like that. So that's diamond. So filled staircase is essentially just a right triangle. So I enter 10, and it's going to output 10 tall, all filled with diamonds. But then going off that, we have outline staircase, which is a little bit more tricky. So this one's going to look like this. So instead of printing diamonds on the inside, we print spaces on the inside. So that's what I want for that. Again, 10 tall starting from 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then moving on to 7, which is sum. So essentially what you do here is you just allow the user to enter numbers, so 10, 20, 30, 40. And then as soon as they put in 0, it outputs the sum, which they say the sum is 100. And then the final one is number 8, which is running sum. And then what this one does is when I enter a number and push enter, it will immediately tell me what the running sum is. So I say 10, sum is 10, 20, sum is 30, 30, sum is 60, 40, sum is 100. And then again, just like before, we put in 0 to exit the program, or exit the summing subprogram and go back to our main program, and then 0 to exit out of our program. So that's essentially what I'm looking for in the program. Any questions about what I want right now?
We see a sample code on like how to do one of those like aspect things like that.
we are, so essentially what you'd want to do in order to print an asterisk is you'd want to say something like this. This is essentially how you'd print an asterisk. So one of the things in order to do it formatting right, you're either going to want to do space star, just like that. That would be one way to do the asterisk, or star space, depending on where you're at.
So you just have to do a bunch of
Yep. So inside, so essentially, so for a very basic, for let's say the staircase is a very basic example. For that one, all you would do is you have your outer loop. You say, I want to go from I to the end that the user entered, and then in your inner loop, you'd say, I want to go from 0 to I. So on your first iteration, you're going to print out 1. On your second iteration, you're going to print out 2. On your third iteration, you're going to print out 4, and so on and so forth. But you'd want to essentially have a for statement that said, for whatever line I'm on, I'm going to printf star as many times as I need to. So that's what I'm looking for with the printf. Does that make sense? A little bit? Maybe? Yep.
How do we run the sample program?
So again, to run the sample program, you go dist assignment 5. And that'll open up my printer menu, and then you can work from there.
Okay, cool.
So that's the basics of what I want from this program. Going back, there are a couple of other things that you should note. So your output should look similar to mine. It doesn't necessarily have to look exactly like mine, though. If you want to take some different steps or print things out some different ways, that's fine. That's up to you. So this assignment is worth 15 points. That's 5 more than usual because we haven't had one in a while. Tentatively, it's going to be due this Friday. However, I don't necessarily think all of it's going to be due this Friday. What I'll probably end up doing is having some of the easy loops, let's say printing the staircase, maybe doing the square. Those will be due this Friday. And then some of the harder ones like the isosceles triangle and the diamond might be due next Wednesday or next Friday. But that's not necessarily the case. If I feel like the class is going well, guys, it's 11:44.
That's okay.
Okay. There's still quite a few things that you should note here still. So if I feel like the class is going well and you are understanding what's happening and making progress, this assignment will be due in entirety on Friday. So what I really want you to do is start working on it today. I know it won't happen, but start working on it today and see what you understand so far. And then come back to me on Wednesday with questions, or come to Help Night tonight, or come to Help Night on Thursday night. Figure out what you don't know, and we'll work on getting you from where you're at, what progress you made to completing this program. So if I don't hear any questions, or if I don't hear anything from anybody, then it's going to be due on Friday. So
Next Friday.
it will be due next August, or the prior August. Yep, that should be 10/23, not 8/23. Yeah, that's 10/23. It's right in D2L, so that's all that matters. So proper formatting is required. I'll deduct up to 5 points for formatting that makes your code hard to read. So if I'm looking through your code and I'm like, what's happening here, or what's the next statement that's going to be executed, I'm probably going to deduct the full 5 points.
So basically,
Remember that you should be indenting each code block you have. So if I have a nested loop,
You still have the format?
yep, sure is. So looking at this loop, or even just blocks of code even. So I enter a block of code, it should be another level of indentation. I enter another block of code, it should be another level of indentation. So remember, you can say format I, break, continue, and we'll just magically format your program. It's not hard stuff to do, guys, but I'm going to need you to, at least at the very, very minimum, like format your code before you submit it. It makes a lot of sense to write good formatted code when you're writing it because it helps you read it and helps you be a better programmer. So it's just not acceptable to not have properly formatted code. And then finally, there's actually going to be also 15 points of bonus points attached to this assignment. So you can get 15 points if you just meet the requirements. But you can also get up to 15 additional points if you meet these additional requirements. So for 5 points, you can use functions correctly. So if I like how you're using functions, and if you write functions essentially for each bullet point, so one function for each bullet point on that list, I'll give you an additional 5 points. And if you write insightful comments that explain why you're doing what you're doing in your program, then I'll also give you 5 points. And if you find something interesting to do while you're writing your program, if you write something in a non-traditional way or write something in a way that we haven't necessarily talked about in class very in-depth, or really think your algorithm that you developed is really cool, just talk about it at the top, talk about why it's really interesting, why you did it that way, and then I can give you up to 5 points for that. So that's it for class today. I just want to really briefly talk, get some things in your mind. So these are the things we're going to work on Wednesday. So we're going to do FizzBuzz, and we're going to do ascending counter. So that's basically all we're going to do on Wednesday. So just look forward to that.
Here's a question. Have you ever heard of Stuxnet?